In this example, we'll illustrate Rolle's theorem with the function f of x equal to cosine of x. And so Rolle's theorem says that if we have a function that is continuous on the closed interval ab and differentiable on the open interval ab, and if f of a is equal to f of b, and then we can find at least one number c in the open interval ab such that the derivative at c is equal to 0. So let's use the function f of x equal to cosine of x. And this is what the graph looks like. This is the cosine of x. And we want to look at the interval from 0 to 2 pi. So a is 0, b is 2 pi. And so 0 to 2 pi. So a is 0, b is 2 pi. The derivative for cosine of x is negative sine of x. If we look in the graph from 0 to 2 pi, you can see that the graph is continuous on the closed interval from 0 to 2 pi. The derivative here also exists for every x in the open interval from 0 to 2 pi. And therefore the function cosine of x is continuous on the closed interval from 0 to 2 pi. And f of x is differentiable on the open interval from 0 to 2 pi because the derivative exists for every x from 0 in between 0 and 2 pi. One of the conditions in Rolle's theorem is that f of a must equal to f of b. So we need to verify that f of a is equal to f of b. F of a is 0, or f of 0. To get f of 0, go back to the function in the place of x, put 0. So we get cosine of 0, which is 1. B is 2 pi, so f of b or f of 2 pi. Go back to the function in the place of x, put 2 pi. We get cosine of 2 pi, which is also 1. And therefore we have f of a is equal to f of b. And Rolle's theorem says that if we have f of a is equal to f of b, then we can find a number c in the open interval from ab, or the open interval 0 to 2 pi, such that the derivative at that c is equal to 0. And so what we're looking for is this. This is 0, this is 2 pi. And we want to find a number between 0 and 2 pi such that the tangent line corresponding to that number is the horizontal. And so to find the number c, we do the following. F prime of c is negative sine x. And so f prime of c be negative sine of c. And then now we set negative sine of c equal to 0. Multiply both sides by negative 1, we get sine of c to be 0. For the interval from 0 to 2 pi, we know the sine of 0 is 0, sine of pi is 0, sine of 2 pi is 0. Zero and 2 pi, they are not in the open interval from 0 to 2 pi. C equal to pi is in the open interval from 0 to 2 pi. And therefore the c we're looking for is pi. One more time, we have sine of c is equal to 0. And there are 3 possible answers to c, because c could be 0, c could be pi, c could be 2 pi. But 0 and 2 pi, they are not in the open interval from 0 to 2 pi. And therefore c must be pi. And pi is right here. And the tangent line corresponding to pi is horizontal.